Hello everyone, I hope you all are doing well. I got an email with a question, so I figured I'd go ahead and go over a couple of more examples, just working through all 6 of these trig functions, given some different information. So here's example 1. I've got 2 sides, one length of 3 units and the other 4 units. If you remember this from geometry, right away the third side would be 5 because that's a Pythagorean triple. If not, you can use the Pythagorean theorem, whether it came out evenly or would be simplified in radical form. So I would go ahead and do 3 squared plus 4 squared, and that would equal my hypotenuse here, which we refer to as c. That would be 9 plus 16, or 25, equals c squared, take the square root, and c equals 5. Alright, so now I've got all 3 sides and I can go ahead and set up all 6 of these ratios. So what I'm going to do is I'm going to write out sine, cosine, and tangent, and then right next to it I'm going to write their corresponding reciprocal trig functions. So I've got the sine of theta, that's going to equal cosine of theta equals, and then the tangent of theta. Alright, so sine is opposite over hypotenuse, so opposite of that angle. I might as well label them. This is opposite, this is adjacent, and the side across from the right angle is your hypotenuse. The side, yeah. Alright, so opposite over hypotenuse, that's 3/5. Cosine is adjacent over hypotenuse, that's going to be 4/5. And tangent is going to be opposite over adjacent, so katoa. Alright, so toa, 3/4. And then I need to remember which trig functions go with which ones. What's the reciprocal of sine? That would be cosecant. Cosecant of theta equals 5/3. So cosine goes with secant, SEC. Alright, and now it's going to be 5/4. And then the tangent of theta equals 4. Tangent of theta is 3/4, so the cotangent, COT, equals 4/3. Alright, so that's example 1. And then if I move on to example 2, and I see this sort of relationship, you might recall that if one side is 5, or x here, alright, if one side is x, and then the hypotenuse is x radical 2, that makes this a special right triangle. In fact, it would be a 45, 45, 90 right triangle, but if you don't remember that, I'm going to go through the Pythagorean theorem again. So I'm going to set up 5 squared, and here I don't know one of the sides instead of the hypotenuse, so I'll put b squared equals 5 radical 2 squared, and then when I square that, remember to square both pieces of that product. So this is 25 plus b squared equals 25 times 2, or 50. So when I subtract 25, I get b squared equals 25 again, which means b equals 5 when you take the square root. Alright, so when I set up my sine, cosine, and tangent here, sine of theta, cosine of theta, tangent of theta, then I'm going to go ahead and set their corresponding reciprocals. Cosecant of theta equals secant of theta equals, and cotangent of theta equals. So I'm going to go ahead and label, this is my hypotenuse, this is the side opposite the angle, and this is the side adjacent. Alright, so sine, opposite over hypotenuse, 5 over 5 radical 2. Alright, which would reduce to 1 over radical 2. And if you remember, we can't leave it like 1 over radical 2. We have to multiply by the conjugate in order to rationalize the denominator. So radical 2 over 2, so this would make it radical 2 over 2. Alright, and then I go through the same exact process for cosine, which cosine is going to end up being radical 2 over 2 as well. And then for tangent, I would do opposite over adjacent, which is 5 over 5, or 1. And then I take the reciprocal of those. So in the previous video, I had talked about how sometimes when I'm taking the reciprocal, it might be easier to look back at a step before you take the reciprocal. So instead of doing 2 over radical 2 and then having to rationalize the denominator yet again, you can look back a step and do radical 2 over 1, which that's already rationalized. So if you go ahead and take the reciprocal and then rationalize that one, you'll still end up with radical 2. And then you would find that the secant is going to be the same and that the cotangent as well is going to be the same. Alright, so that is something that fun about a 45, 45, 90 right triangle is that all the measurements kind of really go together and they repeat, so it makes it easier to memorize. Alright, if you guys have any other questions, please feel free to email me. I look forward to hearing from you. Bye.